Come on, come on, come on, come on. You can do it. Come on, come on. You can do it. You can do it. You can do it. You can do it.
Got a bunch of water in my mouth.
You got a lot of water in your mouth. That's a dirty trick, wasn't it? Hey, Beckett, look, the light came on. That must mean we're doing something.
I guess so.
That's right. This is my friend Beckett. He's a wit. He's an advanced degree wit. You've been around how many years?
A few, quite a few.
Few years, yeah. We got used to the odor. It took 2 years, but after that, it was pretty good. So welcome to Faraday Studios. Well, you know, one of my favorite quasi-holidays, right?
April Fools.
April Fool's Day. You got to celebrate that, right? But we need to do it scientifically because, you know, we like to mess around with things here in the studio, but we really want to learn something, or at least practice something when we do it, right?
Yeah.
I've got some activities. Some we've done before. I haven't done them in a long time, but I'm going to put a little April Fool's spin on it. Does that sound all right to you?
Sounds great.
So the first question is, you know, how strong your lungs are, we want to measure. So this is a lung tester. And I went to great expense, right? I dug these out of the trash can. I washed them now.
Oh, okay. I was going to say.
I dug them out of the trash can, and that's just a regular balloon in there, right?
Yeah.
1, 2, 3, blow. Okay, and then you go ahead and do it.
Can't get it.
You can't do it. How was I able to do it and you were not able to do it?
I don't know. You must have the superior lungs.
I have superior lungs. I have a little wizard magic. You ready for this? Take your finger, pull it right out here, go like this, cock it, pull the trigger, and there you go.
Oh, man.
One more time. Yeah, I got that sucker down there now.
Yeah, mine didn't do that.
Yours didn't do that. You think it's static electricity?
Maybe.
I'll do it one more time.
Okay.
I'll be a little more obtuse.
Okay. Oh.
What did you see?
2 fingers moved.
Oh, is that what it was? That's a dirty trick. What do I have right there?
There's a hole in there.
Yeah, it's a little hole. Did I sucker you?
A little bit.
Yeah, it's a kind of an April Fool's trick, and you could build a whole story around it, right? Well, anyway, let's move on to another one. So grab a bottle. This is the trick you can do it. You really torment your friends. Okay, we've got to get everything leveled there. Tighten the lids there a little bit, and tighten the lids here a little bit. This is just water. You notice I've got a straw that goes down there. Mm-hmm. Right, and I put a little, what did I do at the hole there?
Glued the hole.
I glued this, I wanted to get it airtight there. So you kind of give me a count or something like this to yourself, right?
3, 2, 1, go. That was quite a bit.
That's quite a bit. Okay, see if you can beat the old man.
Okay.
Oh.
What was that?
You're a good-natured wit, aren't you?
Yeah.
Okay, and I ran out of rags.
I'm a wet wit.
Okay, I think it was water.
Hopefully.
Yeah.
Thanks.
Yeah. I did not get squirted in the face. You did. Why
Lucky
is that?
you.
Why is that? Why is that? Why did he get a shot in the face? I did not. Got any ideas?
I think somehow the air is allowed to leave your container, and mine wasn't because I was blowing in as hard as I could, wasn't going anywhere.
You trapped some air in there, didn't you?
Came right back at me.
And got built up air pressure.
Mm-hmm.
And I blew air in here, but it did not push down and blow the water in my face. You do it again.
Okay. Oh, okay.
That's right. So what's the difference, man?
Well, the only way air could be leaving either of the containers is through the top, because the rest of it's, if there was a hole in it, the water would be leaving. So there's got to be some kind of difference in the lids.
The difference is, look.
Oh, you loosened it.
That was it.
You're letting air out that way.
I was letting air out that way. This is what I do for a living, isn't it wonderful?
Yeah.
Squirting people in the face with water. Kind of ashamed of myself. See that bottle out there, that flask? I blew up a balloon inside that bottle. I want you to reproduce this.
Okay.
If you think you could. I mean. Okay. You notice how mine is kind of wrapped around nice and neatly.
Oh yeah. There we go.
Hey, now we're talking.
That didn't work.
Yet I, the great wizard, got a balloon inflated inside that flask. I'll just set this right here as a clue. That's a little heat source.
Okay. Well, it looks like the balloon's like sealed to the flask.
Yeah, keep looking.
And there's condensation at the top.
Oh, condensation. You know, scientists are observant, and he's actually looking at that thing.
There's a little bit of water in the bottom.
A little bit of water. What would a little bit of water do? What do you think?
Well, I bet you heated up the beaker. I just don't know what the water in the bottom would have to do with it.
I wonder what's going to happen when I warm the beaker now.
Let's find out.
And we just ran out of fuel. That's great. It's been a good day here. We just ran out of fuel. Boom! Oh my God, scared him to death. Oh, jeez. God. So I'm gonna, whenever I wouldn't stick glass directly into that, it'd probably shatter. So what you do is you warm it. You come up here and you start warming it a little bit, okay? Mm-hmm. You watch that balloon. Why am I swirling that around, by the way?
So you evenly heat it, so you just heat up.
Spread the heat out. All right. Yeah, I don't want to have a hot spot and break the glass. The balloon is shrinking. Well, what's making it shrink? Oh, what's happening?
Balloon's all the way deflated.
Well, disappeared. Ta-da! Who's the wizard now, huh? How did I get the balloon in the bottle?
I have no idea.
The balloon's doing it itself.
Whoa.
It's alive! It's alive!
Uh-oh.
You saw it right on the camera. That balloon got itself down in there.
Well, I guess what happened was we heated it up and the water turned into water vapor.
Yeah.
And the gas forced the balloon out of the beaker.
Yeah.
But then once we took it off the flame, it cooled back down, went back to water, just left the space in there for the balloon to go back down inside.
You're getting there. That's probably a C+ answer. But what's happening is the only thing that's touching that balloon besides the glass is air out here and water vapor inside. Somehow I've got to get the air out here to push the balloon in because it was the air pushing it in. So I just made less pressure inside than outside. I did that by allowing the water vapor to cool back down to liquid water, made a lower pressure in there. So if I want to get it back out, what do I have to do? Because the air pressure is pushing on it right now.
Got to heat it up again.
Yeah, and what does that do?
Higher pressure inside.
Yeah, so they're down, the pressure pushes it back out. So what's happening inside right now?
Heating up the water is turning into gas and the pressure is going up.
Yeah, the pressure is increasing inside because we're, oh, there it goes.
There we go.
Let's see how far we get.
Can we get it to inflate?
We get a flake? Come on, let's get the flake up above. It's trying, isn't it? Hey, there you go.
There we go.
There we go. That's what we think of you. Got you interested, didn't it?
Yeah.
And that, oh, there it went.
Uh-oh.
Yeah, that'd make you jump. There's an empty bottle in the refrigerator.
Okay.
There you go. So what do you see? This is the magic bottle, you know.
Big bottle, just came out the fridge.
Yeah, it's the magic bottle of Istanbul.
Oh.
And then you find a coin that will just fit in the mouth without falling in. It lays right there.
There we go.
It doesn't fall in.
There we
right?
go. Perfect.
Okay, so now I have a bottle.
And a nickel.
And a nickel. This is Thomas Jefferson, right? So we're going to speak to the spirit of Thomas Jefferson. Thomas, how are you doing, buddy? The spirit of Thomas Jefferson lives in this bottle.
In the bottle.
In the bottle.
So is he from Istanbul?
Uh-huh.
Okay.
It's the Istanbul bottle because of the secret of Istanbul. Yeah. I make this stuff up. Sometimes it makes sense, sometimes it doesn't.
I mean, it makes total sense to me.
That makes sense. And I'm going to take a little water and put it right there on the joint. Now I want you to wrap your hands around the bottle. Thomas, speak to us, Thomas.
Oh, he said something.
You there, Thomas? Thomas, how you doing, buddy?
Must be doing real good.
You're doing real good. Oh. So a little critical thinking development here. What's going on?
Reminds me of the last one with the difference in pressures.
Well, different pressures, yeah, we did that. So how did I change the difference in pressure?
Well, we started with a really cold bottle.
Yeah.
And then we put water on the lip with the coin.
Yeah.
And then when we put our hands on it,
Yeah.
heated up the air inside.
You heat up the air. And what does the air do when it gets heated?
It wants to escape.
You know, molecules start moving around more. They're vibrating like this regularly, and then we add some heat in there, and they bounce on the bottom of that coin. So why do you think I put water around that?
If the air could escape easily,
Yeah, if the air could escape,
then there would be no pressure.
there'd be no pressure. So what's the water doing?
Acts as like a plug in the hole.
Yeah. You know what this thing is I'm messing with?
Is it a stand?
This is called a lab jack. So if I wanted to have something, though, I was just gonna have that, take some string, fold it over, and tie it in a knot. I'm gonna make a bug.
Add a little bit of color.
Add a little color to it, make it look like something, you know. Say, what is that? See, now that kind of looks like something weird, right?
Something.
I want you to estimate, you think you could blow hard enough to make it hit the back of the bottle.
3, 2, 1.
Let's go, come on. Come on. Nope,
Oh, it came out. I think I lost.
blow it in there. There, Now that'll make them jump and scream.
I think so.
Yeah, that'll get them. Why can you not blow this no matter how hard you try?
Well, if I'm blowing in the only hole in the bottle, there's nowhere else for the air to go.
He's getting better, isn't he? When you blow in there, what happens to the pressure inside the balloon?
Builds up.
And what does that do?
And when I stop blowing, it shoots right back out at me.
There you go. One more time.
All right.
Right in your
Got me
mouth.
right in the face, right in the face.
Mouth. That's it. That's good. When that thing goes, oh, right, yeah.
Right in the nose. Got me, basically went up my nose.
Up my nose. That's perfect, man. Hey, we learned some April Fool tricks, right?
Yeah, lots of them.
But there's one rule, because nobody likes being made a fool. So we don't want to laugh at people. We want to laugh with people, right? So we don't want to be cruel. Everybody gets a good laugh, but be kind. Always be kind and humble when you do kind of science tricks like that. Thanks for stopping by Midnight Science Club. Always glad to have you here. I was laughing at him, but I ain't gonna say nothing because he had a bug go up his nose. That was worth it right there.